On September 19, 1991, at an elevation of 10,530 feet in the Ötztal Alps, on the border between Austria.
For 30 years, museums around the world have shown you the face of a man who never existed. Pale skin, thick, dark, wavy hair, brown eyes. That image has been printed in textbooks, plastered on documentaries, and sculpted into a life-sized model that greets visitors in Bolzano, Italy. It is the face of Ötzi the Iceman, the 5,300-year-old mummy pulled out of a melting glacier in 1991. And in August 2023, a team of scientists proved that almost none of it was accurate. The real man was darker-skinned, likely bald, and descended from a population so genetically isolated that he barely resembles the typical prehistoric European we've been taught to imagine. This is the story of how new sequencing technology quietly rewrote one of the most famous faces in human history, and why it matters far beyond one mummy in the Alps. Let's go back to where this all began. On September 19th, 1991, two German hikers, Helmut and Erika Simon, were crossing a rocky, ice-choked gully high in the Ötztal Alps, on the border between Austria and Italy, at an elevation of over 10,500 feet. Something in the melting ice caught their eye. At first they assumed it was trash, maybe a discarded mannequin. It was a human body, a man, face down, partially mummified, his skin leathery and dark from thousands of years pressed into ice and dried by mountain air. He still had hair on his head. He still had his teeth. Around him lay a copper-bladed axe, a longbow, a quiver of arrows, and clothing stitched from at least 4 different animal hides. He had been lying there, undisturbed, for roughly 5,300 years. What the hikers found is now considered the most extraordinary accidental discovery in the history of archaeology, because almost nothing about the recovery should have worked. Ötzi's body survived because of a narrow, almost implausible sequence of events. He died in a shallow rock hollow rather than out in the open. Snow buried him quickly, and that snow compacted into ice. Crucially, the ice in that specific gully didn't behave like a glacier. It didn't flow, grind, or crush the body the way a moving glacier would have. It simply sat there, frozen and still, for over 5 millennia. Then, in the unusually warm late summer of 1991, that ice patch began to melt just enough to expose him. A few years earlier, he'd have stayed hidden. A few years later, and exposure to open air would likely have destroyed the remains before anyone could study them. His discovery was a 1-in-a-million accident of timing. Unfortunately, the initial recovery was rough. Nobody realized at first that they were looking at a body thousands of years old rather than a recently deceased hiker. Workers used jackhammers and ski poles to try to free him from the ice, and in the process some of his equipment was damaged. His bow was broken. Parts of his clothing were torn. By the time trained archaeologists arrived and understood the magnitude of the find, some evidence had already been lost. But an astonishing amount survived anyway, and what survived turned Ötzi into the single most studied prehistoric human being on the planet. His equipment alone rewrote assumptions about Copper Age technology. His axe had a nearly pure copper blade, fitted into a U-handle using leather bindings and birch tar, a level of metallurgical and craft sophistication that surprised researchers who hadn't expected alpine communities of that era to be working copper with this kind of skill. His clothing combined goat, sheep, cattle, and bear hide, tailored with real construction technique rather than crude wrapping. He carried an unfinished longbow, a quiver holding 14 arrows, only 2 of which were actually finished and usable, and a flint knife with an ash handle. His body carried 61 tattoos, mostly simple lines and crosses, clustered around joints and along his spine, in locations that roughly correspond to acupuncture points used in traditional medicine systems thousands of years later. Whether that's a coincidence or evidence of some very old therapeutic practice is still debated. His last meal was preserved in his stomach: ibex meat, red deer, einkorn wheat, and bracken fern, eaten within hours of his death. And his death itself turned out to be one of the great forensic mysteries of ancient history. For a decade, nobody could explain how he died. Then, in 2001, a re-examination of his X-rays revealed something everyone had missed. A flint arrowhead lodged in his left shoulder, having entered from behind and torn through a major artery. That wound alone would have killed him within minutes. Later CT scans, added a blunt head injury on top of that. Blood traces recovered from his weapons and clothing came from 4 different people, none of them him, suggesting he'd either fought off multiple attackers before he died, or that the blood on his gear was already there from an earlier confrontation. Isotope analysis of his teeth and bones traced his childhood to the Eisack Valley in South Tyrol, roughly 60 kilometers from where he died, with his later years spent somewhat closer in the Vinchgau Valley. Somebody chased him, or he fled, into a high mountain pass, and there, someone shot him in the back and left him to die. Every theory about why, fleeing enemies, a shepherd, a trader, a copper prospector, a ritual specialist, remains speculation. What isn't speculation is that his death was violent, and it was intentional. For decades, that was the story. An incredible mummy, a Copper Age murder victim, and, thanks to genetic science, a fairly clear picture of who he was and where he came from. That last part is what just fell apart. In 2012, a team led by researchers, including Andreas Keller and Albert Zink, published the first full genome sequence ever generated from Ötzi's remains in the journal Nature Communications. At the time, it was a landmark achievement, the highest quality ancient human genome recovered up to that point. It concluded that Ötzi carried Y chromosome haplogroup G2A, linked to the early farming populations that spread into Europe from Anatolia beginning around 7000 BC. It found a genetic mix of Anatolian farmer ancestry and European hunter-gatherer ancestry, broadly similar to the blended ancestry seen in many modern Europeans. Based on markers linked to physical traits, the team suggested he likely had brown eyes and probably light skin. Consistent with adaptations, farming populations were thought to have developed as they moved into higher, less sunny latitudes. That reconstruction became the official version of Ötzi. Bolzano's South Tyrol Museum of Archaeology built its life-sized model around it: pale skin, brown eyes, a full head of dark, wavy hair. That model has been photographed by millions of visitors and reproduced in textbooks and documentaries ever since. The problem is that ancient DNA is extraordinarily fragile, and Ötzi's body has one of the messiest handling histories of any specimen in archaeology. He was pulled out of the ice by untrained workers, without gloves, moved multiple times, and eventually examined by dozens of researchers from different institutions over the following years. Every single one of those contacts had the potential to deposit modern human DNA onto the body or the samples taken from it. Ancient DNA naturally degrades into extremely short, damaged fragments, which makes it genuinely difficult to cleanly separate from modern contamination, especially with the sequencing and bioinformatics tools available back in 2012. By 2023, that had changed. A team led by Ku Wang as first author, with Frank Meixner of Urac Research's Institute for Mummy Studies in Bolzano and Johannes Krauss of the Max Planck Institute for Evolutionary Anthropology as senior authors, published a new high-coverage resequencing of Ötzi's genome in the journal Cell Genomics. This wasn't a minor update. It used dramatically more advanced sequencing technology and far stricter contamination detection methods than existed in 2012, and it produced a genetic profile that diverged sharply from the one the world had been shown for the previous 11 years. The corrected genome shows that Ötzi's ancestry is overwhelmingly, unusually, derived from early Anatolian farmers, a higher proportion than has been found in any other known contemporaneous individual in Europe from that period. That's a striking result on its own, because by the time Ötzi was alive, around 3230 BC, most European farming populations had already been mixing with local hunter-gatherer groups for thousands of years. Ötzi's genome barely reflects that mixing. His hunter-gatherer ancestry is unusually low, and the researchers found essentially no trace of Pontic-Caspian steppe ancestry at all, the genetic signature that, starting right around Ötzi's own lifetime, began spreading from the Yamna-associated migrations and would go on to reshape the genetic makeup of nearly the entire European continent within a few centuries. Modern Europeans carry substantial amounts of that steppe ancestry. Ötzi carries essentially none. Krauss and his colleagues have described this as genuinely surprising. Ötzi appears to represent a snapshot of a population that stayed relatively isolated in the Alps, largely untouched by the population movements that were just beginning to transform the rest of Europe around him. Then there's the physical reconstruction, which is where this study really upends the popular image. The 2012 study had pointed toward light skin and brown eyes. The 2023 resequencing found the opposite on skin tone. The corrected genome carries variants strongly associated with notably dark skin pigmentation, darker, researchers say, than nearly any modern European, along with dark eyes. According to Krauss, this actually lines up better with how the mummy itself looks today than the old reconstruction ever did. It also fits a broader, growing body of evidence in ancient DNA research, suggesting that the light skin tones common in Europe today didn't become widespread until several thousand years later than once assumed, likely tied to major dietary shifts as farming populations ate less fish and meat and needed to synthesize more vitamin D through their skin. Ötzi, in other words, lived at a point on that evolutionary timeline well before that shift had taken hold. And then there's the hair. The genome also revealed genetic markers strongly associated with male pattern baldness. Ötzi died in his mid-40s, and researchers now believe he likely had significant hair loss, quite possibly a bald or near-bald head, directly contradicting the thick, wavy dark hair sculpted onto the museum's famous reconstruction. As a side finding, the resequencing also picked up genetic markers associated with an elevated predisposition to obesity and type 2 diabetes, though researchers note his evidently active, physically demanding lifestyle likely kept those risks from ever manifesting. Put it all together, and the man in the museum display case is, in several very specific and testable ways, not the man who actually died in that mountain pass. He wasn't a light-skinned, brown-eyed, thick-haired copper-age everyman with a fairly typical mixed European ancestry. He was a dark-skinned, likely balding, 40-something man descended almost entirely from an unusually isolated Anatolian farming population, living at the exact edge of a genetic transformation that was about to sweep across the continent, and that he, personally, shows almost no sign of. Why did the original 2012 study get it wrong? This isn't really a story about bad science. It's a story about the limits of the tools available at the time. Ancient DNA research has advanced at an extraordinary pace over the last decade, and contamination detection methods, in particular, have improved enormously. What slipped through in 2012 wasn't necessarily sloppy work. It was the ceiling of what the technology of that era could reliably distinguish. That's a genuinely important point, because it means Ötzi's case isn't an isolated fluke, it's a preview. Other ancient genomes, sequenced with older generation technology, may be sitting on similarly outdated conclusions, simply waiting for someone to apply the next generation of tools and find out. Krauss's own institute, the Max Planck Institute for Evolutionary Anthropology, has been at the center of many of the studies that keep reshaping our understanding of ancient human population history, precisely because this field keeps improving that quickly. The South Tyrol Museum of Archaeology, which houses Ötzi's actual remains in a climate-controlled chamber, will now have to reckon with updating a reconstruction that has stood, essentially unchanged in the public imagination, for over a decade. That's not a small cosmetic fix. It's a genuine correction to how one of the most famous individuals in human prehistory is portrayed to the public. What makes this story worth sitting with isn't just the specific details about skin tone or hair loss, as fascinating as those are on their own. It's what Ötzi represents as a case study in how science actually works. He is arguably the most intensively studied human being from prehistory. His stomach contents mapped down to individual plant species, his tattoos cataloged and mapped, his wounds forensically reconstructed, his gut bacteria sequenced, his final hours pieced together in remarkable detail. And even with all of that scrutiny, for over a decade the world had a materially wrong picture of what he actually looked like and where his ancestors actually came from. Not because anyone was careless, but because the tools weren't good enough yet to see past a decade's worth of accumulated contamination from well-meaning human hands. That's the real takeaway here. The final answer printed in a textbook or sculpted into a museum display is really just the best available answer at that moment, built on the best available technology of that moment. Ötzi didn't change. The ice preserved him exactly as he was 5,300 years ago. What changed is our ability to read him accurately. As sequencing technology keeps improving, and as contamination detection methods keep getting sharper, it's entirely possible that other iconic reconstructions from ancient DNA studies will need similar corrections down the line. Ötzi's resequencing isn't the end of his story. It's a reminder that in archaeology and genetics alike, the past isn't a fixed picture. It's a picture that keeps coming into sharper focus, one better instrument at a time. The man who walked into those mountains 5,300 years ago, was shot in the back, and left to die in the snow, is finally being seen with something closer to accuracy. And after 3 decades of research, we're still learning who he really was.